Let me start up with the class. Today I'm going to learn a very new topic. Quite interesting topic also, only if you are going to show the interest. We have learned this 4 types of flip-flops, sorry, shift registers. We have learned this 4 types of shift registers. Can we have the list of it? We have seen 1,
Serial and serial out.
the second one, third one, and fourth one. We have seen all this. Now, is it possible for us to design all these 4 in one? Can we see all these 4 in one? When you see all these 4 in one, then it is called as universal shift register. Universal shift register.
Ma'am?
Yeah?
Ma'am, the last one will be parallel and serial out. You've, ma'am, by mistaken, you've written both the same.
Okay, fine. So when you join all these 4 together, then it is called as universal gate. Now let us see how we can do it and what we can do. Okay, so let us take a new one, not new one. We'll clear all. So first thing, you have to make one document. What is the document? That is, what all operations you want to do. Okay, for example, let us say we have to
We cannot hear you.
no change. You have no change in the circuit.
Ma'am, you are not audible.
Now,
Ma'am, your voice is breaking.
can you hear me now? Students?
Ma'am, your audio is still low.
But why? Everything is correct. Net connection is correct. I'm also putting headphones. Is it so low? Now can you hear me?
Yes, ma'am.
Okay. So one thing where you have no change. Second thing, you can have shift right. Third thing, you can have shift left. Fourth thing, you can have parallel load. You can do all these 4 operations in one single circuit. To do this all functions in one circuit, can you tell me if you're going to have a control pin? If you're going to have a control pin, like in one of these shift registers, you had a control pin. What you had, only one control pin you have, such as S and L bar, which worked into 2 with a NOT gate. Okay, now, so what happened? One control pin worked as 2, either shift or load. It was working. Now, can you tell me how many control pins you want here so that it can work in 4 different options? So now your circuit is what you're working on. Your circuit is, what is it? Serial universal shift register. Universal shift register, where it can work with all the operations of your shift registers. You can remain it as it is, or parallel shift right, shift left, and parallel load. Now tell me how many types of control pins you want for 4 different operations. How many bits you require for something to work with this many operations. So can I tell I need 1 control pin? Will 1 control pin do? Tell me yes or no. I think all the students are there in the class. There are 40 students in the class. 49 students, 50 students in the class. Now tell me, with 1 control pin, can I work with 4 different operations?
Yes, ma'am.
With 1 control pin. Even if for this 1 control pin, even if I put 1 NOT, I can take 1 input from here, 1 input from here. So only 2 options is possible for me. So only 2 options is possible for me. So if I have to work with 4,
Not with 1 pin. We'll need a few more pins.
at least minimum of 2 pins you require.
2 pins.
So that
Yes,
2 to
ma'am.
2 to the power of 2 is equals to 4 different combinations. So now I can tell I can work with 2 different pins which can work for 4 different options. Yes. So now I'm going to have 2 control pins. Let me say I'm going to work with S0. I'm going to work with S0 and S1. I'm going to work with S0 and S1. So I'm going to work with S0 and S1. Okay, so what I will do, I'll put a combination for this. That is, I'll put 0, 0, 0, 1, 1, 0, 1, 1. These are the 4 different combinations which I'm going to work with. So for this 4, first one is no change, serial right, serial left, and then parallel load. So these are my combinations. I have already predefined my combinations. That if I'm going to have 0, 0 as my control pin, I'll be working with the output remains the same. That means what? Just the output remains the same means whatever is at the input stage, we are not loading anything. Remember, we are not loading anything. Whatever is there at the current instant of time has the input, that will be same as the output. Next is serial write. That means what? Whenever you give your clock pulse, the shift will happen, but the shifting will happen parallelly towards right side. That is right shift. Next, left shift is towards the input will be from this end and you will load the registers like this. So this one, and the output will be taken from this end of the last flip-flop. If it is right shift, this will happen, and this, if it's A, B, C, D, if it is A, B, C, D, D will be the output. Similarly, if you say A, B, C, D, A will be, A, B, C, D, D will be the input side and A will be the output side for serial left. And now parallel load is nothing but you will load the input at the parallelly input at each individual register, and you can take it out with the flip-flop at individual flip-flops. So this is about the operations. For this, what you can do. So you should have a control pin with 4 combinations. Can you tell me which kind of circuit can be inserted between each of the flip-flops so that it can take all the 4 options? You have already learned this particular circuit. Tell me one of the circuit name where it takes the 4 combinations of input, not exactly this 4, any 4 combinations of input, and your output, it can work in at a time with any one combination. It can either work as 0, 0 or 0, 1 or 1, 0 or 1, 1. but it has the 4 different options and only one output. What is the circuit called as? Very familiar one. You people will tell, oh ma'am, this one.
Mux, ma'am.
Very nice, very beautiful. You have a circuit called as mux, which will be inserted between each of the flip-flops. Now I will teach you right now for 2 bits. Your job will be to for 4 bits designing. Now I will tell how to design. This carefully listen how I am designing so that it will be useful for you in further classes. I am designing with a block diagram first. I am designing with a block diagram first. That will help you to draw the further diagram. So now I'm taking 2 bit only now. This is my 1 register. This is my, observe carefully students. Okay, let me draw with 3 so that it will be more efficient way. 1, 2, 3. 3 registers, 3 flip-flops. I'll name the flip-flop as A, B, C. And I'm using D flip-flop. So this is DA. Right now I'm not giving anything input. Okay, I'll give. This is D input. This is D input. This is D input. This is Q output. Q, Q. So D, Q, D, Q, D, Q. This is C. I have a clock pulse which is working on the negative clock pulse, and now I am connecting everything to this common clock pulse. Okay, I'm not done more. Okay, this is all simple, which you know what we are doing. Now, the first step is preliminary arrangements we have done. Second one, we are going to design a universal shift register with parallel load. Now you already told me that I'm going to use a mux. So I'll just put a block diagram now. Later I'll teach you the circuit diagram. This is the mux. Mux has 1 output. Mux here I have designed it as, mux I have designed here as this will be the input for D. The output of the mux will be the input of D. The output of the mux will be the input of D. So right now I have told the output of the mux, let us say mux A, MA, MB, MC, mux. Mux has 4 inputs, yes or no? If it's a 2-bit control pin, then it's having 4 inputs. What are the control lines? I have told they are going to work with 2 control lines, S0, S1. Same thing is going to get connected here also, same common line. Okay, so 2 S0 and S1, you can imagine both 4 different combinations. So I have designed a mux here which is going to work in this. Do mux require a clock?
No, ma'am.
Okay, fine. So we are not going to give a clock. So let us number this as 1, 2, 3, 4. 0, 1, 2, 3. 0, 1, 2, 3. Okay. Now, what is the first table? Let me go back. What does my table say? When it is 0, 0, that's all. The minimum connections I have done. Nothing. Now only we have to start the major connections. So what I have done is I've designed the 3-bit universal shift register with parallel load. What I have done, I have just taken 3 flip-flops, 3 mux, because each individual flip-flop has to be connected to individual mux. Each D inputs, it's connected to the output of the mux. So what happens on the internal part of the mux is what we're going to see now. So now first one is, it has no change. Mux has no change. That means what? Mux has no change means what? What do you mean by that? Mux has no change. Tell me, yeah, what does it mean? At least you tell me.
The previous output will be maintained.
The previous output will be maintained. So we have no design required for that part. So if you see here, if you pass 0 and 0 here, whatever is here, whatever we have given the input, that will be passed as an output. Yes or no? And that will be fed as
Yes,
that will be fed for D. So whatever is here, whatever is here, we are not bothered what is there, 0 or 1, whatever was there the previous, before giving the clock pulse, whatever was there after giving the clock pulse, that will be fed here. Similarly here, it comes here, it will come here, feed here, and it will come here. So whatever is the input, this input line, 0 input line will work. Now, I will say 0, 1, 0, 1. That means I'm going to work for number 1 pin. So 0, 1. So what is 0, 1? Go back to this one and see 0, 1 is right shift. That means what? The input is this one. Right shift. That means what? It is going to move towards your right hand side. Yes or no? So one side of the flip-flop should work as an input. So that means I'm going to first feed it in this direction. Sorry. I'm going to first feed my input from here. This input should be fed to B. This one should feed here. The output is taken here. Okay, I didn't tell you something else. In the previous one, whatever was there at the 0th pin should be taken as a output. How will you take the output? You have to drop this line. I forgot to tell that. You have to drop this line because this is the output line. So you'll take the output from here only. So the output will be QA here, QB here, QC here. Okay, now we are going for shift register right. So how will the shift register happen? So that means you are going to load the data. It is loading the data. Now you should recall the shift register right. Shift register, if you remember, we are giving only the input on one side. If it is right, if it is right, we are giving from this end. If it is left, we are giving from this end. Okay, so now we are now going to give an input, this input. So here you will write, this is the input. So this is the input. So the data, whatever you're given here, will be on the basis of the selection line 0, 1, that is 1, will be fed here. When you give the clock, what happens? It will automatically feed here. Now, you should remember the output of the previous, whatever was here, that should be fed where? It should move serially. That should be fed where? To which pin of the next line? Here also at the same time. Here also at the same time you will have 0, 1. Here also at the same time you will have 0, 1. Now, where this output has to be fed, for us to move the data and reach at C, it should be connected to 1. So that when you give here 1, the output will come here and it will be parallelly fed here, to D. And now the output here, it should be fed here. So now when you're giving here 0, 1, it would have fed here, here, and then output will be produced. Yes or no? Understanding, students? All are sleeping? Kindly answer. If not, ask ma'am once more.
Yes, ma'am. Could you please repeat?
Okay. Where should I do? First part you people understood.
001. No changes, ma'am.
Not that one, the other one, the second one. That is 0, 1.
01.
So that is my second step. So I have given 0, 1. So when I'm giving the first 0, 1, it means that it goes for all the mux. So I have put 0, 1, 0, 1 in all the places. Okay. Now, what is my 0, 1 doing? My 0, 1 is right shift. That means one side of my one side of my all connectivity will work as my input. That means now this A flip-flop works as my input. If in case I'm going to work as serial left, then I will start my input from my left hand side. But now I want my serial right to happen. That means my data has to move from left to right like this. So I will use A as my pin now. So if this has to get the input from serial right, my since the combination of control pin is 0, 1, obviously every place of 1 will be active now. So whatever input is there in that point only will be fed in input of all the flip-flops. So now this particular full complex diagram has to work for serial right. Okay, fine. My first one will work as an input because I have to give my serial input. This is the first one. So all my input when I'm giving the individual clock pulses, it will work. So this is not 1, 2, this is input. So now this is going to work as an input and taking all, it can be 10 data, 20 data, 30 data, it doesn't matter what is the data being given, but this works as an input. So whatever is being given as an input here, that is, whatever is given as an input here will be taken as an output here. It will be given to D. D will produce one output for me. Since it's parallel, serial in, I'm not going to take parallel output. I'm going to shift everything till C. So now, if here I have to produce one output means, I have to pass the input to this D. What should be passed for this input D? Whatever was the past output of A should be passed to B. That is only serial shift, right? And whatever was the output of B should be passed to C. So what I will do, the output line, I will feed it to B's input of 1. So now when I'm giving this serial, and whenever in case if I'm going to give the clock here, then immediately whatever is there at this point will be fed as an input. I will get my output. So now I have shifted the data from A, from input, then I've shifted to B. I have to now shift it to C also. So whatever was the previous output here will be fed here. So when I'm giving the clock pulse, though mux does not require clock pulse, whatever is fed as an input here, that only will be taken when clock pulse is working for the flip-flops, right? So now when I'm giving the clock pulse, whatever serial shifts happen, that output only will be produced and given to input of D flip-flops. Now the data will be fed to each individual flip-flops and the output will be taken from here. Leave about this, forget about this arrow mark. The output will be taken from this point only. So now bit by bit, if you're going to give 3 bits here, let us say you're giving 4 bits. So on 4 bits, on series of 4 bit plus 3, 7 clock pulses, you will get all the outputs here. Next, this is about the serial in with parallel load. Now, I will do it for serial input left side. That means now tell me, right side when I was doing, my A flip-flop was my A flip-flop was working as an input. Now when I'm doing left shift, my C has to be as my input. So now my C, when I'm working, maybe my selection lines will change now. My selection lines will become, let me change it with different color. It will become 1, 1, 0. So now since become 1, 0, I will use this pin as my input. Now it becomes, now I'm going to feed the input here. Listen carefully here only, the logic is same. How we are drawing lines is important. Now this becomes an input first pin for you. Now C becomes the first bit, first flip-flop. Now here you're going to feed the input. Automatically when you're giving the clock pulse, the data will come. You will get the output here because flip-flop, when you're taking the output, respect to its output only we have to take. So the first flip-flop you're getting. But when you want to push the data to the B flip-flop, to the next one, which is the second one now. B is the second one. C is the first one. B is the second one. Output is A. That is, we have to take serial output, means we have to take the output from A. That means from this point, we have to take the output. Now, from C, how you can transfer to B? You have to pull the line. This is the output line. Here, from here, you have to take it and go and feed it to the second line of the mux. That is, you're taking the previous output and feeding. That's all. Nothing else you're doing. Because you're moving it from this side. Understanding? And now when you're giving the clock pulse, so here also it will change. Here also it is becoming 1, 0. Here also 1, 0. So now this will get produced. This output, it will be fed to this 2. This is just, once again, I will draw the diagram and show you. This is just for the first explanation. Now, this output is fed here now. Now, is it not moved left shift? Now, finally, the data, when you're giving it, will come here. Then the output will be produced here. From here, you take the output. So 3, if you're giving 1, 0, 1, 1, 4, on the 7th clock pulse, you can see all the output will be on this line. See, you cannot take an output from this end because this is the input side. Output side only, you should drag and take it this side. So this is about your shift register right. Now coming to parallel load, what you will do parallel load? Directly each and every individual flip-flop will work like a input. So you will pass the input, parallelly you will take outputs. One single outputs you will take. How you worked with parallel and parallel out, like that. Done. We have done with a universal shift register. We saw how just taking the output instantly, whatever is there in the flip-flop without any change, you just take it, means we just take it as load and we just take it. So when we want to give the input, just we are going to take from either right or left and then pass the input. So this is about your serial, this one. I'll just show you one diagram. You can just see how you can explain in that same diagram. 1 second. So that the diagram may be a little convenient for you to explain. 1 second.